Okay, so here is the rocket problem example. It's a two-part problem and causes some students a little bit of difficulty. So let's read through it. It says, a rocket initially at rest on the ground accelerates straight upward from rest with a constant acceleration of 49.5 meters per second squared. The acceleration period lasts for time of 5 seconds until the fuel is exhausted. After that, the rocket is in free fall. Find the maximum height, y max, reached by the rocket. Ignore air resistance and assume a constant acceleration due to gravity equal to 9.8 meters per second squared. So I'm going to draw a motion diagram and a couple graphs here first. So the motion diagram, I'll do over here. So it starts on the ground at rest. It's going to accelerate and increase upward, and then let's say at that instant it starts to decelerate now due to gravity. So smaller, 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 small. And there we are at y max, and here is when the acceleration runs out. This is time equals 0, y equals 0. We'll call those the initials. This is some y number 1. This is y number 2, which will be a final. That's y0. And there's some time here, time 1, and some time here, time 2. This has an acceleration upward during that first phase, and this, it's accelerating downward due to gravity because it's in free fall in that second part. Now the way this graph might look, if I did a velocity graph, it's going to be easiest to draw. So it's going to start at rest, accelerate upward pretty rapidly, and then decelerate to 0. So this is my time 1, time 0, time 2. And we know that that area, this area, is equal to the displacement. And we know the slope here is going to be 49.5. The slope here is going to be negative 9.8 because of those accelerations, because the slope is acceleration. So we could use that graph and find the area to find that displacement. But I'm going to use the kinematics equations. Now, what about the position time graph? So it's all positive position. Y starts at rest. It's going to accelerate rapidly up, and then it's going to start to decelerate and be like that. Now, I drew my deceleration phase to be a little bit greater rate. It's going to look like that, where this is increasing speed, so increasing slope as it goes up. Right there's the fuel burns out, so decreasing speed on the way up there, and that would give us how high it goes. So that's the way those two things would work. This is where T1 is, and this is going to be where T2 is approximately. So how do we do this mathematically? Well, we have two different phases. In the first phase, for A1, we've got a velocity initial, which is 0. We've got a velocity final, which I called V1. Actually, I didn't call it anything. That's V1, which I don't know. I've got a position initial, which I'm going to make 0. A position final, which is position 1. That final is position 1, which I don't know. We've got an acceleration in the y direction, which is negative 9.8 meters per second squared. Since that is downward, whoops, sorry, I am jumping ahead. This is actually the positive value. positive 49.5. So be careful, read carefully. Luckily I caught myself. 49.5 meters per second squared. That's here. And that is an up. That's an up. This one is a down. And that change in time over which that happens is 5 seconds. So this is an upward acceleration at first. Now for the second phase, we've got a velocity initial, which is v1. These are the same numbers. That's happening right here on that graph, or right here on that graph, or right there in that diagram. It's got a velocity final. I want max height. So max height is going to happen when it no longer moves up. So that's here when it hits 0 velocity, or here when it has a 0 slope. So I know that's 0. The initial position for it is y1. These are the same. The final of the upward acceleration phase is the initial of the free fall phase. Y final, that's my y2, and that's what I want to find. These I don't know yet. The acceleration in the y direction here is my acceleration 2. That's what I called 2. This was 1. And that is negative. This one is the negative 9.8 meters per second squared. And that time frame, I don't know. Time frame 1, time frame 2. All right, so gotten organized with my lists. I've made sure I've identified values that are the same, and I've indicated ones that are different with different subscripts. And now I can go on. I need to find, if I begin with the end in mind, I want to find this. This is what I want to find right there. Well, I need to get like 4 pieces of information over here to do that. I need 2 more, and I don't have those. That time I don't have. Well, but look, this one is the same as that, and this one's the same as this over here. So if I find those over here, I can plug them in the second. So I need to find this final velocity and this final position to plug them into there. So I'm going to need this, need, and need. And I'll get those from this first phase. So let's find velocity first. So I want to find velocity. I have time. I don't have position. That leads me to final velocity is initial velocity plus acceleration times the change in time. So that's going to be my v1 is equal to my v initial, which is 0, plus my acceleration, positive 49.5, times the change in time, 5 seconds. So plug that into a calculator. You get 2,407. Nope, I'm sorry, 247. 247.5 meters per second. Long day. And now I got to find the y. I found v1. That I got. It's 247.5, and it's up. That makes sense. It's moving up. It's moving up the entire time, so that's a positive number. Now that position, so now that I have that velocity, I got all kinds of equations to use for position, but I'm gonna use this one, that y final is y initial plus velocity initial times time plus 1/2 of the acceleration times the time squared, time interval squared. So that's a 0 plus a 0 times 5, that cancels out, plus 1/2 of 49.5 times 5 squared. And that gives me $618.75. So that equals 618.75 meters. I'm going to carry everything out to the end. We've only got 3 significant digits in all our things. So at the end, I'll round to 3 digits. Okay, I've got that. Plug that in here. I don't have time for this last interval. So the equation without time is that the velocity final squared is the velocity initial squared plus 2a y final minus y initial, the change in y. Well, I've got everything here but the y final. So I'm going to plug them in first, and then I'll do the math. Y final is 0, right? It's going to end at rest. Y initial, that's this. That's the positive 247. 247.5 squared plus 2 times negative 9.8 times y final, what I'm looking for, minus, make sure we squeeze this in, the y initial, which is this, 618.75. 618.75. I'm running out of space there. 618.75, that's that number. All right. Rearrange some stuff. You got a negative 247.5 squared divided by a negative 2 times 9.8 is 19.6. 19.6 plus 618.75. That's going to equal y final. So that's just, I did some algebra. Let's move that around. So 247.5 squared divided by 19.6. Those negatives, reduce. Plus 618.75. 3,744 equals y final. 3 digits, so 3,740 meters is my answer. Hope that was helpful. Have a good one.